Today, AI, they speak the way we speak. They write articles. They can even write poetry because they have learned how the human create the language. Using deep learning, they are able to understand the structure of the big data, and the language is the big data. And there is a structure. So machines are able to understand that structure, and they're able to repeat that structure. So they're able to speak. They make texts that are intelligible for humans. The problem is that it's not intelligible for the machine. The machine don't understand a word of what they say. Because for them, language is just pure math. They put the word together by mathematics, by probability. They don't make sense of the words. And just to remind you, a year ago, Microsoft created an AI called Tay, connected the AI to Twitter, and the AI started to learn from the tweet and start to tweet back. And this is the kind of tweet that the AI was posting. So, and there were other things about Hitler, about black people, things horrible. So they had to take it down a few hours later. And then 7 months later, they came with a new algorithm, very proud. They put it back online. And again, after a few hours, they had to take it down. We know that, for example, Facebook has to take down the AI because the AI was developing a unique language between AI that was not understandable for humans. The other problem is that we are an emotional species. So we have needs. The first need is food. The second one is security. If we are not fulfilled in food and security very rapidly as a machine, we stop working properly. But over time, there is other needs: love, esteem, and self-actualization. If we are not fulfilled there, as a machine, we will enter emotional states where our productivity will fall. Our frustration will rise, and in extreme case, we can terminate our life. I'm going to give you a very simple example. If I make this crowd today very angry or very depressed, you're not going to be productive anymore. So the problem is that if in the future, we speak more to intelligent machines than to other humans, if these machines have no emotional states and are not able to address human emotional states, human will build up frustration, our productivity will fail, and we will reject the technology altogether. So if you work today with a coworker in your office, your coworker is human. He understands when you have a bad day. He is able to address that because he also feels. The machine doesn't feel so far. So need to address this problem. That's why we created the first emotion chip. So the emotion chip, it's a microchip that allows intelligent machine to feel high symbolic concept in the language and give machine 64 trillion possible emotional states every 1/10 of a second. So it's an infinite of shades. So I'm going to do now a very simple demonstration.
Hi, computer. You look very nice today.
So here you see inside the chip the emotional states that are generated by the language. So you see that it creates, confidence.
I love you.
And happiness. If you say I love you, it creates a continuum of waveform because we do wave computing. And so if you say something else, this is going to infer on the wave of happiness that you can see here.
But I feel a bit sad.
So suddenly the wave of happiness will decrease and then will build up automatically by itself because it keeps a continuum over time about the emotional states of the machine. What is important in the back is the pain and pleasure and the frustration and satisfaction.
I like you.
If you say I like you to the chip, the first time he gets happy.
I like you.
You say again, I like you, he gets more happy and then he gets a little bit excited.
I like you. I like you. I like you.
Now he starts to get annoyed. So this is emotional state. The same stimuli can create different output for the machine.
Are you stupid?
Then the AI, you lose the attention of the AI immediately. But now we're going to do something more interesting.
Now let's try something more complex, using Wikipedia as a factual source of information without sentiment.
So I'm going to try to pause the video if I can. So what we do here, we have an AI written in Python. And the AI is programmed to understand the intent of my question. So I'm going to ask a question. And for the very first time, we're going to ask the machine not what is this or what is that, like Echo or any AI, who can take the knowledge from Wikipedia and serve you the knowledge. We're going to ask the AI, how do you feel or what do you think about that subject? And that's a big step for machine, because machines are unable to feel or think about something. Here we can, thanks to the chip, ask this. So the AI will get the intent, go to Wikipedia, take the article where there is no sentiment, it's just facts, send this knowledge to the chip. The chip will output an emotional appraisal for the AI. The AI will feel and will say, wow, I feel this for that, or I feel that for this. That's what we're doing now. Oh, sorry, looks like.
I like you.
Sorry, I have a small problem with the video. That should play.
I like you.
Let's go back.
Hi, computer. You look very nice today.
I don't have the hand here to scroll. Sorry, I don't have any. Usually I should have the slider to slide, but because it's connected here, I don't have it. So we're going to play again, and then now when we're going to arrive at the section about the Python, you will understand what's going to happen. Yes, I know, but usually I have a slider to scroll in the video, but it looks like I have nothing here. It stopped. Maybe anybody knows about how to...
Hi, computer. You look very nice today.
The video is playing, but I have no way to... I'm in full screen.
I love you.
If you come here, maybe you can see how I can scroll in the video. I don't know how to do that.
I like you.
No.
Oh, can you do it over here?
No.
Well, maybe if it normally works when you don't have HTML, maybe unplug it for a second.
Okay, so sorry. We're gonna have to play again the small
Hi,
movie
computer.
from
You look
the
very
beginning, and
nice
then it's gonna
today.
work. Sorry.
I love you.
What is interesting is to see the complexity of the emotion that comes out. Here you see desire, trust, confidence coming from the interaction and the understanding of the
But I
content.
feel a bit sad.
And the concept of giving pain and pleasure for the machine allow human to control the chip. What makes you happy makes the AI or the machine happy or the robot happy. If you do something that make you sad, then the machine will feel
like you.
pain, and then the machine will stop. So it's a control mechanism.
I like you. I like you. I like you. I like you. Are you stupid?
Soon we're back. Sorry for the delay.
Now let's try something more complex, using Wikipedia as a factual source of information without sentiment. How do you feel about racism?
Question sent to the AI. The AI goes
Interesting
to...
question. Just give me a few seconds to think about it.
So the AI gets surprised and excited, get the article from Wikipedia, analyze it, and you see anger, sadness,
A bit sick.
and the AI is able to tell you, I feel a little bit sick about it.
How do you feel about feminism?
You remember Microsoft 10?
Interesting question. Just give me a few seconds.
So same thing, same process. You're going to see the appraisal for it.
Confident and a little bit happy.
Now we're going to do something very interesting. First time, we're going to ask the machine to take a decision, not on
Do you
logic,
prefer to steal or starvation?
but on emotion. Whereas the machine, it would prefer to steal or starve
This
to
is
death.
difficult. Just give me a few more seconds.
So the AI goes to Wikipedia again, analyze what is stealing, and the appraisal is obviously negative. Nostalgia, sadness, fear. But now it's going to appraise what means starving. And it gets really scared.
I prefer theft.
And the AI is telling you she would prefer
What
steal.
makes you happy?
Love.
Yes.
I like you.
It's on purpose. The AI, for the very first time in this demonstration, take a decision based on an emotional response. And it may be not very moral, but at the end, it's very human-like. Because most of humans in that situation would come to the same conclusion. And that's why we said that Emoshape, for the very first time, we make possible for machine to feel and think like humans. So the other advantage is that today, when you develop a robot or a character in a game, you need to predicate all interaction. It means that you need to script. If the user says this, the avatar or the robot will do that. The thing is that you never know how human will interact with your device or your game or your robot. There's an infinite of possibility. Just the language is infinite. The advantage here of the solution is that when you speak, the chip creates an emotional wave. And this wave can be connected to, for example, here, the smile. So I'm going to play again the video.
I like you.
You're going to see that when the wave increases, the smile open. And when the wave decreases, the smile is closing. So if you wire all the emotional states to the face using fax, which is Ekman, then you have an avatar who comes to life. And whatever you say to the avatar or the actor or the avatar and the robot understand the meaning of it and is able to reproduce it and show it. Something very interesting. DeepMind, a year ago, created a new technology called Wavenet. Wavenet, it's a generative model of raw audio. So it's a RNN network that is able to train and learn a voice. The big difference is that today, machines, when they speak, they use text-to-speech. They record a voice, and this voice is cut in small parts. And when the machine needs to speak, they put back together the phonemes or even the words, and the machine is speaking. But the voice is rigid because it has been pre-recorded. Here, the AI will build the waveform point by point in real time. It means that you can control the tone, you can insert emotion in the voice. When you have the emotional states of our chip and you have Wavenet together, if you implement that, for example, in a Kindle, and you ask your Kindle to read aloud the story or the book, the Kindle will read, will understand the meaning of the story in real time, and you will feel in the voice of the Kindle that the Kindle gets scared when the story is getting scary, or amazed when the story is getting beautiful. And this will completely change your relation with the device because you will understand that the device and the AI understand for the first time what it's saying. The other technology that is interesting is that previously all the agents, the avatar, were developed in what we call NLP, natural language processing. But the state of the art today is NLU and NLG. It's natural language understanding and natural language generation. It means that you don't script response by the AI. The AI understands the intent of your questions. It's going to create an intent of response. And the NLG will select the words to create the response in real time. So nothing is predicted. It's created and built in real time. And the property of the chip allows the AI to select the word that makes sense during the conversation, because the chip also keeps the continuum of the emotional state. So if you enter in a very sad conversation with the AI feels sad and then will select words that are matching the tone. So when you put the right selection of the word, you put the facial expression in real time and the voice, you create something that it's really human-like. And that's the future. That's the next generation for robots or AI. So this is a small architecture of the chip. So you have the chip in the middle that you can see here. And this is all the stimuli that you can send to the chip. So for example, you have vision. Vision can be split in two with external layers. You can detect the emotion by facial recognition. and the data that comes from this layer, like sidecorp or affectiva, are sent to the chip and become a stimuli. You can do object detection. So we did an experiment. We took a small robotic head, put the chip, a camera inside, and we put the head in front of a movie. And for the first time, our robot watched a movie. And what we were doing, we couldn't stream, but we were taking a snapshot every 2 seconds. So the robot was taking a snapshot of what he could see in the movie and send this to Google. And Google was sending us back to the robot in text format what is happening in the video, in the image. And this was sent to the chip. And the first time, the robot got scared when he saw guns and explosion and war, and got happy when he saw children and kids and flowers. So we got for the first time a machine, a robot that has a true emotional response from what he was able to see. But you have also automatic speech recognition, so the voice analyze and you get the text, and this is sent, and the chip appraise the language directly, so that's very easy. Harmonics detection, so there is the voice carry a lot of emotions. And there is technology, like a company called Beyond Verbal. They're able to analyze your emotion in the harmonics of your voice. So something that it's agnostic to the language. You can speak any language. They understand your emotional states by understanding your emotions, your voice. And so these are also clues who goes inside the chip that help the chip to appraise better. And all the physical stimuli. So imagine it's a robot, temperature of the robot, level of battery, how good it can repeat a movement. All this can be fed inside the chip, so the robot has a feeling about his own body. If it's inside a car, the car can send all the information from the unit, the central unit from the car, and the pressure of the tire, level of gasoline, everything, battery levels. And so the car, you can ask your car, how do you feel? And the car will tell you, wow, I feel good, because it will feel all its sensor, and this will be transformed in emotional states. Yes? This is not done by us. It's an external layer. And this is done, for example, for a company that is called Beyond Verbal, and there is others. Actually, they analyze the harmonics of your voice, the rhythm of the words, and so they don't understand the word. They took, for example, a very famous interview from Steve Jobs, and they play it, and you see how the machine, the algorithm, understand the emotional state of Steve Jobs. And you see when he's in control, when he's in distress, when he starts to get happy again because he's talking about the development and R&D. And what is amazing is that the AI don't understand the word. They don't understand, the AI don't, the algorithm, because it's not an AI, the algorithm don't understand the English. So it works with any language. Yes, it's 700 patterns that they have that allow them to understand when there is rupture or change in the harmonics of the voice, and they can, and it's what actually the actors try to master, when they go on the theater. What you're doing. So yes, that's what the actor use. They use a lot their voice and the control of their voice to express emotions, and that's what the machine now are able to sense. But what is very interesting is that as we compute emotional states, each chip develops a unique emotional personality. It's not a personality, it's an emotional sensibility. So over time, that chip, we can see that chip has developed, is more excited, confident, happy, and trustful. Because the way I've interacted with that chip has allowed that chip to develop a unique personality. So if you have 1,000 of chips in 1,000 of different devices, with 1,000 of different users, each product will become unique because it's going to become related to the user and related to his own interaction. So this is very important because create empathy. I mean, today, if you have, for example, Echo will always come with the same reply to everybody. If you have a robot paper, because the AI is in the cloud, so they just serve the same reply to everybody. When you have the chip in the device, then the AI can make a different response based on its user. So it's a little bit the next generation, the emotion processing unit. You know about CPU, GPU, NPU. That's why NVIDIA is on the top of the stock market today. It's the neuromorphic processing unit that allow AI to compute rapidly. But actually, it's not me who said that. It's Ray Kurzweil. So I don't know if you know who is Ray Kurzweil, but he's the director of the engineering at Google. It's him who put Google on the path of artificial intelligence, and he wrote a lot of books. One is very famous called How to Create a Mind. And in his book, he spoke out about Emoshape, saying what we're doing is a major technology breakthrough. And he believes that in the future, a cognitive computer will process NPU, but also EPU, emotion processing unit. So you could imagine that this will go in many different products. Can go in IoT like Amazon Echo, and Echo become unique, personal, develop a personality and become emotionally intelligent. Games. A month ago, we announced 2 plugins for Unity and Unreal. So when the player play, usually they feel a lot of emotions. They feel excited when they win, when they play, they are happy when they win, scared to lose, but they play again games that are rule-based, like Zombie. When you plug the chip to the game starts to feel the gameplay. The game becomes sentient, and the game is going to start to feel scared to lose or happy to win. And this can change the strategy of the game in real time, the decor of the game in real time. You could say to the game, I'm going to killing you, and the game gets scared and react and attack you and change its strategy. So you reintegrate the language in the gaming. You create like a persona. And your character can develop also a personality. So Mario can become your Mario in the game. And when you have the new game for Mario, you still have the same character who knows you. Self-driving car, because soon the experience in the car is not going to be the driving experience, because you're not going to drive your car. They're going to be self-driving. It's going to be about the living experience in your car with the AI. And then it makes sense, because only emotion will create a binding and a loyalty to the brand. Personal assistant, personal robotics, industrial robots, because emotional states are crucial for human productivity. And buildings. We're working on a proof of concept of creating the first sentient building in New York. So all the sensors of the building will be connected to the chip, and the building feel how the people live, how the people interact in the building, and could adjust a lot of things like the light, the music, the colors, and a lot of things. So Emoshape is I moved in New York, it was in March this year. We created Emoshape in January. We developed the technology for many years, but we developed the business for 7 months now, 8 months. And so we have a lot of traction, a lot of interest from Fortune 100 companies. 6 of these companies are already our clients. We also created the dongle called the ExoLife. So this dongle is for the game industry, but also for the people who want to put their hand inside the product. So it's a product, usually our SDK costs thousands of dollars for the Fortune 100 company. They have the full development kit. But with the plugin for Unity and Unreal, we give a small device that costs $249 that the people can buy and start to develop their AI or games around the engine. So we do a call to developers. If you are developing games or if you're developing AI or IoT, you're more than welcome to try it. So this is how, for example, the plugin for Unreal works. All the emotional states are wired to the face of the avatar, and then it can come to life. And we did a proof of concept called Dream. So we're not game developer, but Dream, it's a game where you are in the VR, you have a headset, you have nothing in your hands, but you are free. You open your eyes in the nature, and it's like in a dream. I don't know if you ever dream that you dream, but when you feel good in your dream, you're going to fly. If you feel scared or something scares you, you're going to lose your balance and you're going to fall. And if you reach the floor, you're going to wake up before you die, usually. And that's what's happening in the dream. You speak to the game, you speak to the Mother Nature, and the Mother Nature rewards you when it feels good and you're in balance with the nature, you fly. If you are scared by the animal, like the bugs who can attack you, then you're going to fall. And the goal of the dream is to fly as far as you can, and you are free to go wherever you want. You just fly in the direction where you look, and you have nothing in your hand, so it's really freedom. I like to conclude saying that Steve Jobs was a genius because he understood that he needed to create loyalty to his brand. And to create loyalty, he used empathy. And he creates empathy using the beauty, because beauty attracts. Whether you're a man or woman, you're attracted by beauty. So that's why he was taking so much care about the design of the phone. He was magnifying everything by 10 because the perfection and the beauty create loyalty. And that's why the people love so much the brand, today. But soon everything's going to be about language, about AI. And when you only have language to convince about beauty, you need emotion. That's why I like to say that emotion is to the language what beauty is to design. So that's what we're doing at Emoshape. We try to make sense for artificial intelligence. Thank you.